Hi students, today in this drill we'll look at the slope of a line and we'll see how the slope changes for different lines, right? And we'll also look at the interpretation of slope, right? And we'll also be looking at some special points on the line. Now let's look at, let's take a line. And for that, we'll go to this function line, select just any 2 points out here, right? Click on this arrow button again. Now you can move around the line, right? Now, if I click on over here and check the value, we'll get an equation, right? And this is the equation of the line. It looks kind of messy out here. So what we're going to do is go to the settings, and again, as usual, we'll bring the decimal to 2 places. So the equation of this line is y equal to 0.78x minus 0.37. Now, this is in the form, this is the slope intercept form of a line. 0.78 is the slope and minus 0.37 is the y-intercept. But what is slope? All right. Now we'll see about that. Let us figure what is the value of the slope. It is already 0.78, but we'll see how it changes as we change the orientation of the line. So we'll go to this measure function, click on slope. Let's find the slope out here. The slope, it is 0.78. You can see it's 0.78 here also. Now, the idea of slope is as the line gets steeper, your slope will become greater. All right. The steeper the line, the greater the slope. So if you see here, the slope is 0.61. If we make this line steeper, you see that the slope is increasing, right? And as you make it less steep, the slope also gets decreased. Cool, right? Now, check this thing out. In this case, we have got a positive slope. A line running in this direction, right, will always have a positive slope. What if we change the orientation of the line? You will see that the slope is turned negative, right? So a line running in this direction will have a negative slope. Now, what is the slope of a line which is parallel to x-axis? What we'll do is bring it slowly closer to, parallel to the x-axis. We'll notice, let me just bring it up here. You will notice that the slope approaches 0. So the slope of a line which is parallel to x-axis is 0. There is no slope at all. Now, what is the slope of a line which is parallel to y-axis? Check this out. Check the slope out here, okay? Now this line is perfectly parallel to this y-axis, and we have got a small question mark out here. Right? This question mark, it suggests that the slope is not defined. Now, why is the slope not defined? How is it possible? That's the question. Now, if we have the coordinates of 2 points, let me take this. Let me take the coordinate of this. It is 5, 4, and let's take the coordinate out here. It is 1, 1. Now, how to calculate the slope? slope is given by this formula that m, which is the slope, is represented by y2 minus y1 upon x2 minus x1. So in this case, we have got the 2 points 5, 4 and 1, 1. So this is kind of like the x1, y1, and this is kind of like the x2, y2, right? So slope in this case is 4 minus 1 upon 5 minus 1, which is basically 3, 4, and 3/4 will give you 0.75, right? Now, let me clear this up. All right. Now, if we take a line which is parallel to the x-axis, now here the slope is 0. Now, why is this slope 0? Notice the 2 point out here. 1. Let's check what its coordinate is. .98 and 0.91, 5.97 and 0.91. Now, what we are going to do is take the slope now. So m is equal to y2 minus y1, 0.91 minus 0.91 divided by 5.97 minus 0.98. You will notice that the numerator becomes 0 and it will have some value in the denominator. Nevertheless, since the numerator is 0, the slope is equal to 0. The slope is equal to 0 because the height of this line from the x-axis, it remains the same, right? Now, what happens when we bring this line parallel to the y-axis? Why do we get 0, not defined as the answer? This is a line which is parallel to the y-axis. How do we know it's parallel? Because its x coordinates are the same. If you notice, the x coordinates are 0.98 respectively for both the cases. Right now, x coordinate is kind of like the horizontal distance from the y-axis, right? And this distance is always equal to this. Now, if you apply the formula for slope, m is equal to 5.21 minus 0.91 divided by 0.98 minus 0.98, which is 0. Now we cannot divide a number by 0, and hence we'll get this to be not defined. Right? Now, let me clear this up. Now, what happens to the slope of a line when it is parallel to another line? Now, let's consider this line to have a slope of 0.98, and let's draw a parallel line. For a parallel line, we'll go to this parallel line out here. We'll select a point and a parallel. You can see if I move this point, the line gets parallel according to the orientation, right? Now let's figure out what is the slope of this parallel line. We'll go to this measure button again. On slope, we'll figure that the slope of these two lines remains the same throughout. So we can definitely say that slope of parallel lines are equal to each other, right? Now, what happens to the slope of a perpendicular line? Let me delete this one. All right, then let's draw a line just parallel to this given line, perpendicular to this given line. So perpendicular line, let me take through this point, and this is the line through. Right? Now this line will always be perpendicular. We can check this by putting a point out here at the intersection, and let's figure out what is the angle between C, D, and B. Okay, let me take it in an anti-clockwise direction. B, D, and C. You will notice that it is always a right triangle, right angle. All right, remove this. Over here, you see that the slope is equal for the original line is 0.67. Let's see what is the slope of this perpendicular line. Now, if we measure the slope of this perpendicular line, you will find out to be negative 1.48. Now, what is negative 1.48? If we just go to this Geogebra button, and if I write -1 upon m, right? So you can change the slope out here, and you'll see that the negative reciprocal of the slope of the parent line is equal to the slope of the perpendicular line. Or you can also do this thing. You can multiply the original slope with the new slope m1, okay, m_1, and you will always get this to be -1. So the product of slopes of perpendicular lines will always give -1. Or you can say that the slope of perpendicular lines are negative reciprocals of each other. Move around and you will see that m1 has changed, a has changed, but m times m1, it is always equal to -1.